In this lesson, we shall focus on grade 11 June examination past questions. We shall first look at mathematics paper 1, which was out of 100 marks written in 2 hours. We're going to focus on provincial examinations and how students should prepare for their June exam, in particular with a specific focus on grade 11. We continue as follows. The students in 2019, grade 11, had to deal with questions of the following nature in their June examination, solving for x given a quadratic equation of the form given. Right, so if we're given this one here, x squared minus 6x equals 7, what do we do, Tando, to solve for x here? What do we do? Let's talk about it. What do we do?
We should express it in standard form.
We write it in form. So we write this quadratic equation in standard form, and this equals 0, and this is what we call the standard form, okay, of the quadratic. Next, what do we do now? What do we do now after written in standard form?
Factorize.
We factorize. What are the factors of this? How do we factorize this? What do we do to factorize this? Okay, there are too many ways to factorize this, but I'm going to use a general approach where we multiply x squared by minus 7. Right, because you're by yourself, I'm going to engage you more. Right, so you have minus 7x squared. You multiply x squared with minus 7. We identify the factors of minus 7x squared that give us minus 6. And those factors are minus 7x together with x. Okay, at which point we were able to realize that we have here with us x squared minus 7x plus x minus 7 equals 0. We take out the highest common factor of the first two terms. What is the highest common factor of these first two terms, Tando? X, leaving us with x minus 7, and then here we have x minus 7, and the result is 0. Next, what do we do here?
We have the same. We must remove one bracket. So factor out one bracket.
Factor out one bracket. So we take out the x minus 7, and then I'm just crossing it out deliberately because then you can see we're left with only x plus 1. And then this is x equals 7 or x equals minus 1. Right, so we continue right now to solve the next question. So now to solve this one, we need to solve for x given 3x squared minus 2x equals 14. What do we do here, Tando?
We must also write it in standard form.
We must express it in standard form. Excellent stuff. So we have 3x squared minus 2x minus 14 equals 0. And this is in what? Is in standard form. So what do we do next?
We factorize.
Okay, what are the factors?
We use.
Right, use the correct formula because they've already said correct to 2 decimal places, right? They've already said correct to 2 decimal places, and so we're going to use the quadratic formula, which is x equals minus b plus or minus the square root of b squared minus 4ac out of 2a, which means x is minus, you have minus 2 plus or minus the square root of minus 2 squared minus 4a. C is minus 14, and you have this 2a, which is 2 plus or minus the square root. So what do we have under the square root sign here? Right, so under the square root sign here, you would have the following. So you have 172. Please check this because you're going to have exactly this here. At which point we have 4 times 3 times 14 which is that, yeah, 172, all divided by 2 times 3, which is 6. The results, therefore, are, so you're able to get the following. Right, you're able to see, therefore, that this means that x is 2 plus the square root of 172 out of 6. Or x equals 2 minus 172 out of 6. And therefore, what is the answer here? Okay, so we're going to use a calculator to get the results here. And this is exactly what? At this point, it is exactly 2 comma. Right, it is exactly 2 decimal comma. Right, it is exactly 2 decimal comma 52. And this one is exactly minus 1,85. Okay, so and these become the results here. And we must thank Senula for joining us as we are practicing together. It is very, very essential. We are getting full steam exam preparation. From now on, we shall be looking at focusing on exam preps, exam preparations to make sure that it is all very well. And obviously, we're going to be getting up our coverage of exams. I'm going to be bringing exam after exam after exam after exam as part of our strategy to prepare for the oncoming examination, and we are certainly good. As a consequence, the two values of x obviously is obtained here are as follows, meaning that x is approximately of these 1.1.2, 2,52, or x is approximately minus 1,85, like this. Okay, then we look at 1.1.3. 1.1.3. How do we solve for x here? Given this one, okay, I'm starting with something a bit easy, and then we shall see if time is going to allow us. We're going to look at the second paper, but I want us to go through the June things you need to know. Okay, right. How do you solve for x here? How do you solve for x here? Where do we start? Tando.
You take x to the other side.
You take x to the other side, and this is what we get. The next, what do we do?
And then you square both sides.
We square both sides, like so. Okay, I'm trying to engage you more, and I'm gonna engage Senula as well. Next, what do you do here? Okay, we square this, and if you square 2, you get a 4 minus 2 times minus x times minus 2 minus 4x plus x squared, which means it is x squared. We have minus 4x minus x, which is minus 5x, and then you add 2 to get a 6, and this is equal to 0. Okay, I'm going to be quick in factorizing this. Factors of x squared are x and x. Factors of 6 that give a minus 5. What are those factors of 6 that give a minus 5 here? What are those factors? They are minus 3 together with minus 2, so that we're able to get that x is equal to 3 or x equals 2. But obviously, if you put 3 here, 2 minus 3, what is 2 minus 3? It's a minus 1, meaning that x cannot be 3 because it's going to make the square root negative. It's going to make the square root to be equal to negative. So it is not the case. So the correct answer would only be x equals 2, because if you put 2 here, 2 minus 2 is 0, and then 2 minus 2 is 0, and then that is that. Okay, so yeah, we're good. We're good. We're good. Okay, but if you look at 1.1.4, 1.1.4, with x squared,
Factorize first.
we factorize this. Okay, what are the factors of this, Tando?
Oh, we factor out x.
Factor out x, the highest common factor, and we're left with x plus 7 is less than 0. Next, what do we do?
We
What do we do? Senulo, what do we do?
Critical values. So you find the critical values.
Values. We find the critical values. What are the critical values here? Anyone? X0, X minus 7. They are the critical values. Right. Smiley face. We put minus 7, 0 here. X. Right. So when this quadratic is negative, it means therefore we're focusing on the part that is less than 0 here. So which means we have this here. We have this. So now the correct answers to this, or the correct solution to that, it means therefore that minus 7 is less than X less than 0. So that is the answer to 1.1.4. The next question, any idea here, any different view? You agree with this answer? Okay, next we look at 1.1.5. In 1.1.5, we're given 3 to the power x plus 3 minus 3 to the power x plus 2 equals 486. Okay, yeah, I'm going to be loading a lot of physics, a lot of chemistry this coming week. Get ready. Right, so now at this point, if you have 3 to the power x plus 3 minus 3 to the power x plus 2 equals 486, what do we do here to solve for x? The question says solve for x. What do we do here?
So we know that when numbers of the same base are multiplying, we add the exponent. So we will reverse the order.
We reverse that. So which means it is 3 to the power x, 3 to the power 3. 3 to the power x, 3 to the power 2, and this is actually 486. Next, what do we do? Next, what do we do?
I think we express 486 in its prime factors.
Yeah, we can do that. Senulo, what do you think? Senulo here? Yes, Senulo, what do you think?
That we must simplify 486 so we can have it to a power of 3.
Okay.
We can have it to the power of something.
Yes, okay, yeah, that's good. And then what is it in terms of that? Okay, that's going to be hard for you. But there is a common factor 3 to the power x here. If you pull out 3 to the power x, so 3 to the power x pulled out as a common factor, then you cross this out. And then you're going to be left with 3 to the power 3 minus 3 to the power 2 is equal to exactly that part there, which is 486. So what do we do here? What is 3 to the power 3? 486. What is 27 minus 9?
16.
Okay. You close?
Oh.
What do we do here now? What do we do here? What is the next step? If you have this, what do you do here? Please talk to me. If you have 3 to the power x times 18 equals 486, what is the next step?
Divide by 18.
Divide by 18, both left and right. So you have 3 to the power x times 18. You divide the left by 18, but also you have 486, you divide by 18. Right, so which means that you have 3 to the power x equals, what is 486 divided by 18? 486 divided by 18 is what?
27.
It is exactly 27. Well done. It is 27. Good. Just write 27 there. Right. Because now we're getting 27, what do we then do after this? Which is 3 to the power x. Now we have 27. Okay, just a minor thing here. Okay, right, we have 27, and 27 is what? Can you write
3
it as
cubed.
3? 3 cubed. What do we do now here?
We drop down the exponent.
Yeah, we equate the exponents because the bases are the same, and therefore we equate the exponents, and therefore since the bases are the same, and we have 3, 3, then we equate the exponents getting x equals 3. And that is the solution to this. So here we have x equals 3. Right, the next thing is we're going to do 1.2 right now, given the following expression. Let us look at 1.2. 1.2, given these, determine the value of values of x over y. So we've been given x squared plus 2xy minus 8y squared. The result is 0. What do we do now to solve for x here? What do we do to solve for x here? Okay, we don't need to solve for x, but we need to determine the values of the ratio. We must find x over y. What do we do now to find x over y here? What do we do? Senulo, what do we do? We need to find x over y from this, but what do we do? What is the next step? What is the next step? Please talk to me. I believe you're not mute. You're able to talk. Let's talk. What do we do?
So we try to simplify so we can have x and y by themselves, and
Yes, we
then we
try to
can then
simplify.
divide
Yes.
them, and then divide them in order to get their ratio.
Good. One way to simplify this is to factorize this. What are the factors of x squared? X and x.
X and x.
What are the factors of minus 8y squared? That give 2. 2xy.
4 and 2, sir.
4 and 2, well done. So there's a 4y, and then there's a minus 2y, and then this is going to be like this, because 4 is bigger, it must have positive, so that we can have a plus there. And this is what we have. And at this point, it means that x is minus 4y, or x equals 2y. Next, what do we do?
Simultaneous.
Right, remember that we must just divide both sides by y, because you must have x over y. This is only x. So you divide the right by y and this one by y. But also here x equals 2y, you divide this one by y, this by y, which means x over y is minus 4. And then here this means x over y equals 2. So we got the values of x over y. X over y is minus 4. X over y is 2. And we are done. So we determined the value of values of the ratio here. Next. We need to hence determine the value of values of x and y if this is the case. So what do we do now? Because at this point, in this 2.1, we found that x over y is minus 4, but we find that x over y equals 2. But we also have that x plus y equals 6. Then what do we do here? Because now we need to determine the values of x and y. So this is becoming simultaneous now. It's becoming simultaneous. So if it's becoming simultaneous, then what is the next thing to be done here at this point? Right, so from this one, from these two equations, we can just cross multiply and say this implies that x is minus 4y here, or x is 2y, like so. And then what do we do next? All right, we solve with this equation. So we have x plus y equals 6. Right. So now We then say, for instance, we want to get the value of y. So we can take this one and plug into this, which means that at this point, what we have, wherever there is x, we put minus 4y plus y equals 6. What is minus 4y plus y? And then also, if you have x plus y equals 6, wherever there is x, you put this one, you put 2y, which means that you have 3y equals 6. And then here, which means is minus 3y equals 6. You divide by minus 3, which means y is minus 2. Here you have 3y equals 6. You divide by 3, and then you have y equals 2. Y equals what? 2. Right. So that in the end, what we're then getting is those values over there. They're those values over there. So what are essentially the values? Okay, so we got the y's, and then we must get x's. So x is, according to this equation, x is minus 4y, which means that it's minus 4. You put minus 2 there, which means that x is 8. X is 2y, and then here you have 2, and the y is 2. What is 2 times 2? It's a 4. Right, so the values are, the y values are actually minus 2, 2, and the x values are exactly 8 and 4. 8 or 4. Right, yeah, we have got the results there. Any question or any remark, question, contribution to make about this question before we move forward? Where's the contribution to make before we move forward here? Where's the contribution to make before we move forward? Right, so we move to the next question. In the next question, the next question is about the nature of roots. If 3 is one root of the equation, determine the value of k. What do we do here? What do we do here? If 3 is one root of the equation, we need to determine the value of k. What is the first step? Anyone? What is the first step?
Move k to the other side.
We can move k to the other side. Okay, good. But the fact that 3 is one root, what does it mean? 3 is one root, it means that x equals 3. And obviously, if you have 3x equals minus k, x is 3, so you have 2 into 3 squared minus 3. 3 equals minus k. Next, what do you do? What is 2 times 9? 3 squared is 9. 2 times 9 is what? It's 18 minus 3 by 3. 9 equals minus k. What is 18 minus 9? It's a 9 equals. Okay, if 9 is equal to minus k, what is k? What is the numerical value of k? We can divide by minus 1, getting that k is equal to 9. So, yeah. At 2.1.1, then we have that k is equal to 9. In 2.1.2, calculate the value of the other roots.
No, sir.
Yes?
Isn't k equal to -9?
Well done, well done, well done. I'm happy that you are wide awake. You're wide awake. K equals minus 9. Thanks to your observation, Tando, there. So indeed, k equals minus 9. Right, so let us continue. Right, so move to the next thing. Calculate the value of the other roots. Calculate the value of the other roots. How do you find the value of the other roots? Anyone? So obviously at this point, we are sure that k equals minus 9. What is the value of the other roots? What is the value of, okay, once you get k equals -9, you plug it into the equation. So you're going to have 2x squared minus 3x equals minus k. So you have 2x squared minus 3x equals minus. So you have a -9. Okay, getting 2x squared minus 3x equals +9. And then what do we do? All right, we have 2x squared minus 3x minus 9, and the result is 0. What do we do here now? Okay, because now we need to calculate the value of the other root. We got that 1, if 3 is 1 root, meaning x is 3. Right, so what do we do here? We need to factorize this. What are the factors of this? I'm going to be very brief in factorizing this. What are the factors of this? So the factors of this are 2x plus 3, x minus 3. 2x plus 3, x minus 3. And therefore, this means that x is minus 3 over 2, or x equals what? X equals 3. Those are the factors. Okay, so yeah. So, and that means, therefore, we conclude that x equals minus 3 over 2 is the other root. X equals minus 3 over 2 is the other root. Right, so because the question said calculate the value of the other root, so the other root is x equals minus 3 over 2. 2.2, it's Maltinius equations. It is your favorite. I know that you guys love Maltinius equations a lot. Let's get started and get cracking with these Maltinius equations in 2.2. Right, so in 2.2, then you have exactly this equation. What do we do now to solve for x? Right, so you have been given the equation 2 equals x minus. Okay, 2 equals x minus. So you have 2 equals x minus 2y. Can we make x the subject here? If you make x the subject, moving the 2y to the other side, it's going to be 2y plus 2. And let's give this one a name. Let's call it the first equation. And we have another equation, which is exactly 2 equals x squared minus 2xy plus 3y squared minus 2. 3y squared minus 2. Like this. Okay, so what do we do now? We call this one the second equation. Right, and once this has been done, we do simultaneous. I know that you guys love simultaneous, so I'm not going to waste a lot of time with this one. So you substitute equation 1 into equation 2, which means 2 is exactly in the place of x, you put 2y plus 2, you square, minus 2 in the place of x, you put 2y plus 2, you put y, and then you have 3y squared minus 2. If you square 2y, what do you get? You get 4y squared. 2y times 2 times 2. What is 2y times 2 times 2? Anyone? Anyone? So 2y times 2 is a 4y times 2, which is 8y. 2 squared gives us a 4. Okay, here if you distribute by opening up the brackets, what do you get? You have minus 2 times 2y, which is minus 4y times y, which is minus 4y squared. So this one gives us minus 4y squared. So this would give us minus 4y squared, and this one gives us the minus 4y plus 3y squared minus 2. This one cancels this. 4y squared cancels 4y squared, leaving us with exactly 3y squared. Done with 3y squared. 8y minus 4y gives us exactly 4y. And then we have 4. This 4 minus 2 gives us a 2, which cancels with this. So we're left with only this here. Okay, this is good. Y, which is 3y plus 4, equals 0. Y is naught. So y is minus 4 over 3. Goodness me. Okay. Which x is 2y plus 2. Okay, if y is 0, we use this equation to get the values of x, moving from here right to the side. So when y is 0, you put here 2 by 0 plus 2 here. So x equals 2, is 2y plus 2, but y is minus 4 over 3. Minus 8 over 3. Which is exactly minus 8 plus 6 over 3. What is minus 8 plus 6? It's minus 2 over 3. So we've got the following values. We've got x equals 2, x equals minus 2/3. We've got y equals 0, y equals minus 4/3. And these are the answers to this multivariate equation. Where's the question here? Maybe you're seeing a mistake. Please let us know. Maybe something is missing that we need to add. We need to subtract something. Please let us know. Please let us know. Nothing is, everything is okay. We have to assume that. Okay, because you guys are quiet. Next question is 2.3. In 2.3, we need to simplify this one. So if you need to simplify the fourth root, okay, we're looking at junior exam preparations here. Fourth root of this to the power that 27 to the power x plus 2. Right, so we continue. So, right, so at this point, what do we do now here? We need to simplify this. Where do we start? Anyone? Anyone? Right, so it becomes therefore the fourth root. You express everything to the base 3 under the radical sign. Under the square root sign, everything to base 3. So this one is 3 to the power x. Then the 9 you express to the base 3, but it becomes 9 is 3 squared. And then there's x plus 1. And then it is divided by 3 to the power 3, and then it is exactly x plus 2. So you have the fourth root. So which is 3 to the power x, 3 to the power. Here we have 2 times x, which is 2x plus 2, and this is 3x plus 2. What do we do here after this? Okay, because we've already written everything to the base 3 in the under the square root, so 3 to the power x plus 2x plus 2 minus 3x minus 2. Okay, yeah, we have that. Which is this. Which is the fourth root. Okay, you have x, 3x 2x 0. So, okay, and if we make the square root smaller, just become too huge of a square root. Make it smaller. Okay, so this is like the 4th root, remember? Right, so now we have 3 to the power 0. Okay, let us check. There's a small typo. 3 times x is 3x, and then 3 times 2 is a 6, yeah? Right, so let's just rectify the part. So 3 times 3x is going to be 3x plus 6. And then this one is going to be minus 6. Right, and then now in the end, then this one is going to be exactly a minus 4. So if you have 3 to the power minus 4 and you raise it to 1/4, 3 to the minus 1, which is 1/3. 1/3. Therefore, the result here is actually 1/3. Where's the question? Annie, maybe there's something missing. Let us know. There's an error somewhere. Maybe you're like, okay, there's an error. Please rectify that. It must be a 7. It must be a 5. There. Nothing. Is everything okay? I would assume everything is okay. And then now we'll proceed to the next question. The next question is table 4. Determine the value of values of m for which this one has 2 roots of equal magnitude but opposite sign. So you have 2x squared plus mx equals 5x plus 8. 2 roots of equal magnitude but opposite side. We must find the values of m. What do we do here? What do we do here? Anyone? Anyone home? Anyone home? Anyone home? So we need to determine the values of m for which 2x squared plus mx is equal to 5x plus 8 has 2 roots of equal magnitude but opposite what? But opposite sign. Right, so what do we do here at this point? What do we do here at this point? What do we do here? No one knows. Sanulo. What do we do here, Sanulo?
So we find the discriminant.
We can find the discriminant. That's on point. We express it first in standard form. Right, we express it first in standard form, and this equals 0, which means we have 2x squared, we have m minus 5x minus 8 equals 0. Then what do you do here? You think you find a discriminant, and then what do we do with the discriminant? Right, what do we do with the discriminant? I'm giving you a minute. Please try it quickly. Hello, my dear. Okay, thank you, my dear. Thank you, my dear. Sanulo, how far?
Still writing, sir.
Okay. Because we want to find the values of m. I must tell you that this question can be done without the discriminant. It can be done without the discriminant. But we are interested in determining the value of units of m for which this equation has two roots of equal magnitude but opposite sign. Right, so what do we do? No one knows. Tando, what do we do here, Tando? What do we do, Tando?
Okay, so 2 seconds.
Okay. Right. Please let us know what we need to do here. Please let us know what we need to do here.
Do we write it in standard form?
Yes, we've written it in standard form because standard form means that it is of the form a squared plus b plus c equals 0, and it is the form that we have.
Then we must factorize.
What are the factors then? What are the factors then? What are the factors then? Okay, we want to find the values of m. What are the values of m? Okay, we can clearly see that for that to happen would require that m minus 5 be equal to 0. And m becomes 5, because if m minus 5 equals 0, then we shall have that 2x squared plus 0x minus that equals 0, and 2x squared minus 8 equals 0. You divide both left and right by 2 like this. Okay. Divide by 2. And if you divide by 2, both left and right, what we are seeing here, okay, it was quite a tricky question, a little bit. So you then have x squared minus 4 equals 0. And this means that x squared equals 4. You apply the square root on the left, square root on the right, which means x equals plus or minus 2. And we're able to see, therefore, that x is 2 or x is minus 2. So these are two roots of equal magnitude, but opposite signs, because we have 2 now here, and minus 2, and these are actually obviously of equal magnitude 2, but they're of opposite signs. One is plus and the other one is what? Is minus. So this is all. This is what you're supposed to do. This is what you're supposed to do. But obviously, we continue. Right. We continue. Where's a question about this one? Where's a question about this one? Is there anything that you don't understand here?
Yes, sir. Because me, sir, what I used was the nature of roots for this one.
You use
I tried to
roots.
Yes, I tried to use the b squared minus 4ac is equals to the discriminant formula to get the root. Yes, but it doesn't look the same as yours. The approach is not the same as yours.
I agree, the approach is not. So this was a tricky question. It was a tricky question. So yeah, so it's gonna be a bit difficult with the nature of roots, but yeah, you can use the nature of roots and argue your way out of it. But this will be yes.
I was not supposed to use the nature of roots. I was just supposed to focus on m.
Yes, we're just supposed to focus on m. play around with the values of m. A very tricky question because the m was only here. So you're supposed to just look at the values of m that can work. And the examiner just made it, because now one way to do that, the nature of roots can be used, but it's going to be very complicated with the nature of roots. But also the nature of roots will give you lots of possible solutions at the end of that. For example, the nature of roots would be delta is b squared minus 4ac. And the b, because it's already in standard form, is m minus 5. Minus 4a is 2. And c is minus 8. Giving us the discriminant equals exactly m squared minus 10m plus 25 plus 64. This is exactly m squared minus 10m plus 89. Okay, just write this one clearly here. Right, at this point, then what you're getting is that this is exactly equal to m squared minus 10m plus 89. You got something like this?
Yes, sir.
I would imagine you got something like that. And then now, what did you do at this point?
I tried to factorize, but it didn't look like it was gonna go well.
Yes, yeah, thank you so much for trying that, and I'm happy. Yeah, but it's just that the new curriculum has messed up the nature of roots. Anyway, they moved it to grade 11 now. It's some good benefit. It is our hope that this whole syllabus needs to be restructured. This new curriculum needs to be restructured, and then obviously this one here now you would say, you'd have to factorize this, etc. But it has complex roots. It has complex roots, or it has something called imaginary roots. It is imaginary, right? It is imaginary roots. Okay, complex roots, very appropriate, a very appropriate description. But yeah, that's something that becomes part of this. So you have the imaginary roots. Imaginary roots. Okay, yeah, that's what we have. But this is the method we're to use there. Next question. Right, in question 3 now, we're looking at the number patterns. Let's deal with these number patterns. Right, 3.1, the following sequence is given, which is 7, 3, minus 1. Determine the general term of the sequence in the form that. What is the general term of this sequence? Where do we start here? Where do we start? What do we do? Anyone home?
We first figure out the first difference, sir.
There's a first difference. Okay, what is the difference there, Senulu?
We must first find out whether it's a geometric, arithmetic, or linear equation.
Okay, yes. Well, what do you think? What do you think? Is it arithmetic or geometric or quadratic? Or which one? So if you say 3 minus 7, what do you get?
4. And
So
then
it is
4 again, so it's linear, sir.
It's linear, right? So it is an
So
arithmetic.
arithmetic,
Yes, it is arithmetic. Okay, I'm excited. Right, you've already learned much of these. Okay, so yeah, linear is the arithmetic pattern. Okay, if it's arithmetic or linear, but then what do we do?
And then we calculate the general formula.
Then
Because
it means, yeah, okay, so the general formula in terms of K, so you're gonna use TK equals A plus what? K minus 1 times the common difference. So you have TK equals, what is the first term of this?
7.
Then you have K minus 1. What is the common difference? It's a minus 4. That is the common difference. So you have 7 minus 4k plus 4, which means that tk is minus 4k plus 11. Right, so that is the answer. So because it said determine the general term of the sequence in this form, which means that tk is actually minus 4k plus 11, and that is the answer. Okay, let's look at 3.1.2. Which term in the sequence will be equal to minus 237? What do we do here, and what is the first step?
We substitute negative 273 into the tn place or
Well
tk
done.
place.
Good, right. So we know that our tk is actually minus 4k plus 11. And if they say which term in the sequence will equal to that, so we then say the minus 4k plus 11, this term is 237, which means minus 4k, it's minus 237 minus 11, which means we have minus 4k equals, if you have the minus 237 minus 11, what you get? It's minus 248. Then if this is the case, what is the numerical value of k? So we can divide both left and right by -4. Minus 248 divided by -4, which means k is equal to what? It's equal to 62. K is equal to 62. So any question? That is the answer to 3.2, but where's the question here about this? Where's the question about this? A different view, a different suggestion. What do we do here? What do we do here? What do we do? Next question. So in other words, which term in the sequence will be equal to this? It would be, the term is going to be the 62nd term. Right, obviously in 3.2 now, given the following quadratic sequence, which is 0, p, 2, and 6, calculate the value of p. Okay, the quadratic sequence, what is the value of p? What is the first step here? Given the following quadratic sequence, 0, p, 2, and 6, calculate the value of p. What is the value of p here? Anyone? What is the value of p here?
One.
How did you get it?
So it can only be 1. The number between 0 and 2 is 1.
All right. But I'm expecting a different answer to that.
Yes. So we must either use the the general term in order to
Yes.
find the value of p. So get the
Yes.
general term and then substitute the
Yes, good.
second term to get.
Yes. What do you think the value of p is, Tando? What do you think, Tando? Tando, what do you think the value of p is? Is Tando sleeping? I hope not. Okay, the question is to calculate the value of p. Okay, if this is a quadratic sequence, what is the value of p here? And what do we do, Tando?
You must use the formulas.
Which one? What formula exactly? Because there are too many formulas we learn in school. But which one? Remember, we're practicing here. So I'm trying to see what you think about these questions. These are like past exam questions. What's your take, Tando? Okay, that's easy because it's quadratic, then you must find the differences. Quadratic, you must find the differences. So you must say p minus 0, which is p. 2 minus p. 6 minus 2. What is 6 minus 2? The 4. And then you find the difference here. Here you have 2 minus p, which is 2 minus 2p. 4 minus 2. What is 4 minus 2? It's 2. And then it's going to be plus p because you're going to say 4 minus this. If it's quadratic, it means that this must be constant. The second differences must be constant because these are the first differences. And these ones here become the second differences. So now if these are constant, it means 2 minus 2p is 2 plus p, which means that here at this point, you have 2 minus 2 equals p plus 2p. What is p plus 2p? 0. You have 0 equals 3p. Okay, if 0 is 3p, then what we get the numerical value of p to be? 3p, you divide here, which means 0 is p. 0 is what? So calculate the value of p, it means p equals 0. P equals what? 0. Right, so determine the expression for the nth term of this sequence. Determine the expression for the nth term of this sequence. What is the expression for the nth term of this sequence? Anyone? So at this point, we already know that p is 0. We got it by calculation, p is 0. But if p is 0, then we're asking the question, determine the expression for the nth term of this sequence. What is the nth term of this sequence? Anyone? Quickly, please talk to me. What is the nth?
So you must calculate it first.
You must calculate it. How do you calculate it?
The formula, sir.
What is the formula?
Tn is equals to an squared minus pn plus c.
Well done. Thank you so much.
Plus tn.
Yes, that's fine. I get you. I get you. But I'm trying to make sure that we are sure of this. Okay, so that is, so we've already got that p is equal to 0, which means that we shall have 0 here, and then we shall have 0 because p is 0, and then 2, 6. We find the differences here. 0 minus 0 is 0. 2 minus 0, 2. 6 minus 2, 4. 2 minus 0, 2. 4 minus 2 is 2. And then now, in the spirit of this, here you're getting 0 to 4, 2, 2, which means 2a is this one, 3a plus b is this one. Okay, that is what we do. So if we have that 2a equals 2, we divide by 2, which means a equals what? A equals 1. And then once you get that a equals 1, then we must be able to get the b here, which means that we have 3a plus b equals 0, which means we have 3 times that, which is b equals 0, and this is b equals minus 3. So you'd have therefore that b equals what? Minus 3. After having obtained b equals minus 3, what is the value of c? How to get the value of c? So this one is a plus b plus c equals the 0 here. Okay, if you have that a plus b plus c equals 0, and your a is 1, your b is minus 3, and this is the case, 1 minus 3 is minus 2 plus c equals 0, which means c equals 2. In the end, what you're then getting is that Tn is an squared plus bn plus c, which means that Tn is, what is our a? Is n squared, our b is what? Is minus 3n, and our c is 2. And this is the formula. And then the formula is Tn equals the expression for the nth term. It's this one. We can write it here as n squared minus 3n plus 2. Yeah, that's what we have. That is what we have. And that is the expression for the nth term. Show by okay, show why this sequence will never have a negative term. What do we do now? Okay, here we already got that Tn is actually equal to n squared minus 3n plus 2. Show why this sequence will never have a negative term. What do you do here? what do we do here? How do you show that this sequence will never have a negative term? How?
So I might be wrong, but I think we try and figure out the sum to infinity.
Okay. Obviously, the sum to infinity, we do it for the geometric patterns. But now, okay, to show why this will never contain, this sequence will never have a negative term, we must, because this one is quadratic, we must deal with the minimum value. The minimum value, because this is like a parabola that has a minimum vertex. It's a parabola that has a minimum vertex like this. You can look at it as a set of integer values. In this case, therefore, the minimum value of this is minus b over twice a, which is minus. Okay, you have the b here, which is going to be exactly minus 3 over twice a, which is 1, giving us exactly 3 out of 2. 3 out of 2, 2 complement times into 3 goes 1, remainder 1/2. Okay. Now, what then is the meaning of this? So it means that the minimum value is at this position. Right. So now, but the first term is 0 here, but also we know that p is 0. And the second term is also 0. So we have the first term is 0, the second term is also 0. Right. And also, because the first term is 0, the second term is also 0, there's no term that is going to be actually is going to have the position of 1.5, because 1.5 is actually what? 1.5. 1.5 is, okay, this is the minimum value here of these. So this is like the value of n. So this is telling us that the value of n is 1.5. And now we cannot say the value of n is 1.5 because we're looking at the number of terms. So the number of terms cannot be 1.5. It's either term number 1, term number 2, term number 3, and that. So obviously, if we then say n equals this, which we use a minus b over 2a to find the value of n, there is either the first term, the second term, the third term, but it can't be 1.5. Okay. T is not equal to 1.5. Why? Since the n, or you can call it n, is not equal to 1.5. Let's put it that way. Just call it n. Right, you can just say n is not equal to 1.5. Why is n not equal to 1.5? Since n is a natural number, so natural numbers do not contain 1.5. Okay, the set of natural numbers, for those who forgot primary school, natural numbers are 1, 2, 3, 4, and so on. These are natural numbers, in which case 1.5 is not a natural number because it's a decimal. Right, so because of that, we conclude therefore that no terms could be negative. No terms can be negative. No terms can be negative. Because we want to get n. And n now, always to get n, we use this formula for the, because this graph is like this. So the minimum value, we want to get the negative terms, because now these are positive terms. So this will have a negative term, will possibly be the smallest one. Yeah. And you're able to see that if we want to get n, we're getting a 1.5, and 1.5 is a decimal, meaning since the number of terms they are integers, they are natural numbers, no terms can be negative, and therefore we have shown that this sequence will never have a negative term. Think about it. This is an exam question, but very, very tricky. Let's look at the next point. In the next point, there's a person called Anne and Jerry. Anne and Jerry look at the following patterns. Pattern 1 has 2 dots. Pattern 2 has 2, 4, 6 dots. Pattern 3 has 3, 6, 9 dots. Anne says she can derive the general formula for the number of dots by taking the number of columns in each pattern and multiplying it by the number of rows. Okay. Jerry says if he increases the pattern number by 1, squares that, and then subtracts the pattern number increased by 1, he will get the general formula. Who is correct? Justify your answer. Okay, what is the answer to this question? Who is correct? Who is the correct one here? And why? Who is the correct one here and why? Right. Why? Who is correct? Is it Anne or is it Jerry? Okay, I repeat. Anne and Jerry look at the following patterns. Pattern 1, there are 2 dots. Pattern 2, 2, 4, 6 dots. Pattern 3, 3, 6, 9 dots. Anne says she can derive the general formula for the number of dots by taking the number of columns in each pattern and multiplying it by the number of rows. Jerry says if he increases the pattern number by 1 and squares that, and then subtracts the pattern number increased by 1, get the general formula. Who is correct between the two guys? Who is correct? So let us look at N. Let's look at N's general. N's general term. N's general term is actually Tn equals. So N's general term, N says that she can derive the general formula for the number of dots by taking the number of columns in each pattern and multiplying it by the number of rows. Right, like at this point, there is 1 column, and how many rows are there? 2 rows. So you have 1 column, you have 1 column, and then you have 2 rows. Here you have 1, 2, 3 rows, and 1, 2 columns. 1, 2, 3 rows. 1, 2, 3 columns. Okay, so right, so N's general term is this. So you can see that if this one is 1, then is 2, this one. So this 2 is 1 plus 1. Okay, let's just. Okay, because these things are like, we call them number patterns. So if this one is 1, then this one is 1 plus 1. Okay, if the columns are 2 columns, then this one is 2 plus 1. If this one, okay. So anyway, but what then N is saying is that the Tn is going to be, okay, for the number of dots taken by the number of columns in each pattern multiplied by number of rows. So number of columns. So you have the number of columns and the rows are N plus 1. Okay, let's look at Jerry. And also this one, you can write it as N by N, which is N squared plus N. Okay, let's look at Jerry. Jerry's general formula. Jerry's general term. Right, with Jerry's general term, Jerry says that if increases the pattern number by 1, okay, increases the pattern number by 1, squares that, and then subtracts the pattern number increased by 1, you'll get the general formula. So he takes the pattern number, and the pattern number is n, and increases by 1, and he squares that. And then he subtracts the pattern number increased by 1. So he subtracts the pattern number increased by 1, right? You will get the general formula. Who is correct? Okay, so if you look at this one of Jerry, n squared plus 2n plus 1 minus n minus 1, meaning it is n squared plus n. So who is the correct one here? Who is the correct one here? Okay. Who is the correct one here? Right. So obviously we investigate this and check very, very carefully. And check very, very carefully. But what you can see is that this one, n, got n squared plus n. And also Jerry got n squared plus n. And these guys now are getting the same formula. So as a consequence, what we're able to see, so T1 is 1 squared plus 1 using both formulas, 1 squared plus 1, which is 2. T2 is 2 squared plus 2, which is 4 plus 2, which is 6. T3, which is 3 squared plus 3, which is 9 plus 3, which is 12. Which is okay, this is a 369. But obviously we can really see that this is exactly 2, which corresponds to this, and then it is 6, which corresponds to that. So we can clearly see that they actually both have some degree of correctness, and therefore we're able to see that they are both correct. They're both are correct. Both are correct. Both are correct. Okay, let's continue now. Both are correct. Right, given f of x equals that, given f of x equals this expression, determine the coordinates of the y-intercept of f. How do you get the y-intercept in 4.1? Tando? How do you get the y-intercept of f?
We say at y-intercept x is 0.
And the y-intercept x is 0, right? So let x be equal to 0. So in other words, when x is 0, you would have, because the equation of the function is that one is f of x equals that. So we have f of x, which is minus 6 over x minus 3 minus 1. Getting f of 0, which is minus 6 over 0 minus 3 minus 1. This is exactly 2 minus 1, which is 1. Y-intercept. So you have x is 0 and y is minus 1. X is 0 and y is minus 1. And those are the, it's a plus 1. It's a plus 1. Right, obviously here we have the 2 minus 1, which is a 1. So it's a plus 1. So in other words, the coordinates of the y-intercept, they are 0 and 1. They exactly are 0 and 1 there. Okay, so we continue. Now, in the next question, 4.2, the question says that calculate the coordinates of the x-intercept. How do you get the x-intercept? 4.2, we're interested in the x-intercept. How do you get the x-intercept? Senulo, how do you get the x-intercept? Right, so we let y be 0. In the function f of x equals minus 6 over x minus 3 minus 1. Okay, if y is 0, then you have 0 is minus 6 over x minus 3 minus 1. Y 1 equals this here, which means x minus 3 equals minus 6, which means x is 3 minus 6. What is 3 minus 6? X is minus 3. So, which then means that the coordinates are x is minus 3 and y is 0. X is minus 3 and y is 0. These become the coordinates of the x-intercept of f. Where's the question? Maybe you're seeing a mistake somewhere. Please let us know. You're welcome to let us know if you make an observation somewhere, somehow. You're welcome to let us know. Right, so now in the next question, you need to write down the equations of the asymptotes of f in 4.3. Right, Sanulo, what are the equations of the asymptotes? What do you think? What are the equations of the asymptotes in 4.3? They're x equals 3 and also y equals minus 1. This one is called the vertical asymptote. Vertical asymptote. And this one is called the horizontal asymptote. Horizontal asymptote. All right, so in 4.4, sketch the graph of f on the diagram provided, clearly indicating all asymptotes and intercepts with the axis. Let us draw a rough sketch here. This is the x-axis and that becomes the y-axis. X equals 3 is the vertical asymptote. And y equals minus 1 remains the horizontal asymptote. Right, so we have seen the intercept with the axis, like the x-intercept is minus 3 and 0. So you have minus 3 together with 0. That is the x-intercept. And then now we also have the y-intercept we've got, which is 0 and 1, where y equals 1. So it's exactly at 1 here. And therefore, we need to sketch this particular graph there. So the question becomes, how will this graph most certainly look like? You can actually be able to see that the graph is going to be exactly like so. And the other part of the graph will be actually most definitely there. Put it here so that you have exactly this graph, and this graph is the graph we want. And we have sketched a graph, but obviously sketched a graph on the diagram sheet, clearly indicating all asymptotes and intercepts with the axis. We have shown the y-intercept and the x-intercept there, so we are done with that part. Okay, let's look at 4.5. Right, determine the values of x for which f of x is greater than 0. What is the answer? Tando? Tando? What's the answer? Tando, what's the answer? Determine the values of x for which the function is positive, bigger than 0, f is bigger than 0. What's the answer, Tando? What's the answer, Tando? What's the answer, Tando?
X has to be 1 and above.
Okay. Okay, that's fine. Right. Obviously, we're looking for at the values of x for which the function is positive, but you're able to see that the function here is negative because it is below. And the function is positive, it is positive, and it is 0 there, so it is positive. You put an open circle here, it becomes positive all the way there. It is positive there, and it is negative there. It is positive here. Here it is negative there. So the function is clearly positive where? It's clearly positive from -3 to the value 3 there. Right, so it is positive from -3 to 3, so x lies between -3 to 3. The function is positive. So when is the function positive? It is positive when you're at -3 up to 3 here. That is when it is positive. It is negative on the other parts there. Okay, so let us look at the next question. 4.6, you need to be able to calculate the average gradient. Calculate the average gradient of f between -2 and 0. So at this point, you have -2 for x and you have 0 for x, right? And therefore, when x is -2, you put it here in the place of x. So you have this one, which is this one. Goodness me. Okay. Then now, right. In other words, at x equals -2, let's calculate these things here. Show a bit more steps. Right, so at x equals -2, what you have is you have y equals -6, -2, -3, -1. This is -6 over -5, -1. 6 over -5, -1. This is 6 plus 5 over -5, like this. And this is exactly 11 over -5. So you're getting 11 over that is 11 over 5, like that. And so, but also the other one, you have the other one. So at the other, at x equals, because average gradient -2 and 0. When x is 0, you put it there. That's me. F of 0 is -6, 0, -3, -1. F of 0 is 2 minus 1, which is 1. Okay, so you have 1 here. What is the average gradient, which is y2 minus y1, x2 minus x1. Right, so is x1, y1, and this is x2, y2. And y2 is 1, y1 is -11 over 5 divided by x2, which is 0 minus 2. In which case, therefore, it is exactly 2, and you have 1 plus 11 out of 5. And this is 5 plus 11 out of 10, and therefore it is exactly 16 out of 10. Okay. Let's see now. Okay, there's a small typo here. Right, this is a small typo in the numbers. I need to change something. Right, obviously, because you divide the -6 by -5, you get a plus. You get a plus. So this is going to be minus. 6 minus 5. 6 minus 5 is exactly a 1/5. So you have exactly 1/5. Okay, because we want to find the average gradient, and average gradient is given by the formula y2 minus y1 over x2 plus x1 is the average gradient. Right, so you come here, you remove this one and this one, 1/5. Right, so yeah, come here, y2 it's a 1, y1 is 1/5, x2 is 0, x1 is minus 2. 1 minus 1/5 divided by 2, which is 5 minus 1 out of 10. You multiply the top by 5, the bottom by 5, giving us a 4 out of 10. 4 out of 10 gives us 2 out of 5. Let's check this one. It is correct. It is correct. So this means therefore that the average gradient is 2 out of 5. Average gradient is 2 out of 5. Right. We continue. We continue. Right, we continue. Okay, yeah. Right, just move on, move forward, and yeah. So the average gradient is 2/5. 2/5. Right. Let's look at 4.7. One of the axes of symmetry of F is an increasing function. Determine the equation of this axis of symmetry. How do we start? Quickly, anyone? Anyone? One of the axes of symmetry is what? Is that? So obviously something that we need to realize. The axis of symmetry, you have the asymptotes or x equals 3, y equals -1, y equals -1. These are the asymptotes. These are the asymptotes. So these asymptotes so we continue. So now if you have to deal with the axis of symmetry, that is an increasing function. So there's an axis of symmetry that is going to have a positive slope. So there's always x plus c, and the other one here is y equals minus x plus c. Each one of these are actually what you call the axis of symmetry. These are both what you call the axis of symmetry. Right, axis of symmetry. So if these are the axis of symmetry, you just have to choose one of them. Just have to choose one of them, the one with the positive slope. Simultaneously, you can use the formula y minus y1, which is f into x minus x1, and use the weight through x is 3, y is -1. x1, y1, y minus y1, which is -1. The slope is 1 into x minus x1, which means that we have y plus 1 is x minus 3, which means y is x minus 4. Goodness me. All right, friends. So that one of the axis of symmetry of F is an increasing function. Determine the equation of this axis of symmetry. It is y equal to x minus 4. Right, like this. Okay, let's look at the next thing. Let's look at the next question. We are cruising on us to finish this paper. Right, the next question on looking at graphs and functions. We've had the rectangular hyperbola, but we have also the parabola graph. So the graph below shows the graphs of f of x equals minus x squared minus 2x plus 3 and g of x equals mx plus c. The graph of g passes through point E on the y-axis. E is the y-axis and intersects the graph of f point C here. Okay, the turning point of f and point A respectively. Right. Point A and point B are the x-intercepts of f, and the line CD is the axisymmetry of f. Line CD is the axisymmetry of what? Of f. Determine the coordinates of the turning point of f. Determine the coordinates of the turning point of f. Right, want to find the coordinates of the turning point of f. How to find the coordinates of the turning point of f? Right. Any question? Who knows how to find the coordinates of the turning point of f? So obviously here you want to find the turning point, and the turning point is obtained by using the formula minus b over twice a, and then you put minus here. The b here is minus 2 over twice a. A is minus 1, which is 2 over minus 2, which is minus 1. So that in the end is y equals minus x squared minus 2x plus 3, which means y is minus. X is minus 1 squared minus 2 into minus 1 plus 3. So what is the answer to all this? If you square this one minus 1, you get a 1, getting a minus 1 plus 2 plus 3. And this is 2 plus 3, which is exactly a 5 minus 1, giving us a 4. Right, so the coordinates of the turning point are x is minus 1 together with y equals 4. Calculate the length of AB. So we've already seen that the coordinates of C are minus 1 together with 4. We want to find the length of AB from here to there. How do you find the length of AB? To find the length of AB, we note that both A and B are the x-intercepts. So we first find the x-intercepts of the function f. How do you find the x-intercept? So you let y be 0. You let y be equal to 0. If y is equal to 0, you have minus x squared minus 2x plus 3 equals 0. And then you have x squared plus 2x minus 3 equals 0. X figures of x squared, x, and you have plus 3 minus 1, which means x is minus 3 or x is 1. So here you have minus 3, and there you have a 1. And simultaneously, it means that the coordinates of A here are minus 3, 0, and the coordinates of B are 1 and 0. I'm going to send you homework on the WhatsApp groups to find the length of AB. So what is the distance between minus 3 and 1? Anyone home? Length of AB. Anyone home? What is the length of AB? Here. What is the distance between minus 3 and 1? So to get the distance between minus 3 and 1, this the minus 3 and 1, this is just on the horizontal axis. So you take the largest number. The largest number of minus 3 and 1 is 1, and then from it you subtract the smallest number, and then this is 1 plus 3. What is 1 plus 3? 1 plus 3 is 4, and therefore it is 4 units. Okay, now at the end, now we actually are looking at the following. Determine the equation of G. We want to find the equation of G. How do we find the equation of G? Right, to find the equation of G, we deal with the following, 5.3. Right, you already know the coordinates here, -3, 0. And you already know this one. It has the coordinates -1 and 4. Obviously, this one here, it's -3 and 0. Right, so you already know is -3 together with 0. Right, so this is actually -3 and 0. And if you want to find the equation of G, and G is this straight line. So what we then are going to do is to find the slope, x1, y1, x2, y2. So that's want to find the equation of G. So you find the slope, God, hc, y2 minus y1 over x2 minus x1. Oh, okay. So yeah, over x2 minus x1. And therefore y2 is a 4 and y1 is 0 divided by x2 it's -1 and x1 is -3, and therefore this is 4 over. This is exactly 3 minus 1, which is a 2. So you have the slope of AC, which is exactly 2. It is certainly a dimensionless entity, the slope. Good. Okay, now this line passes through any of these points. You can use this point if you said so. We're going to choose. It passes through this line. It passes through C with the coordinate -1 and 4, x and y. So that in the end, we have y minus 1, which is 10 into x minus x1, which is y. This is x1, y1, which is exactly 4, 2 into x minus x1. So which means y minus 4, which is 2x. This is plus 1, which is plus 2. Y, which is 2x plus 6. Right, so in the end, then now to find the equation of G, we're able to see therefore that the equation of G is actually 2x plus 6. So that we're able to see therefore that the equation is 2x plus 6. It's exactly 2x plus 6. Right, so now you need to calculate the maximum length of line CE. The maximum length of line CE. Right, so if you want to find the maximum length of line CE, here is C and here is E. Right, so at this point, C has the coordinates -1 and 4. C has the coordinates -1 and 4. This one is exactly equal to 2x plus 6. Okay, at this point, when x is 0, y is 6. When x is 0, y is 6. In this case, then we can find this the maximum length. Okay, how do you find the length? Because you already know the coordinates of C and E. So to find the maximum length of CE, then when I say CE is nothing other than the square root of x2 minus x1 squared plus. Right, and then we continue. Right, we continue there. Right, we continue to then say we have actually y2 minus y1, and you square this, which is CE will then have the square root of, okay? If you look at CE, we have x1, y1, we have x2, y2. What is x2? It is actually 0, and x1 is a -1 squared. Y2 is 6. Y1 is a 4 squared, which is exactly the same as the 1 squared, and 6 minus 4 is a 2 squared, is a 4. And then this is actually the square root of 5 units. Which is the square root of 5 units. The square root of 5 units. That is CE. Okay, we continue. So determine the values of X for which this is going to be exactly the case. Right, determine the values of X for which F equals G. Right, so we know very well this is -3 here. We know very well that B has the coordinates 1 and 0. And we know very well that this one has the coordinates -1 together with 4. So determine the values of X for which F equals G. If this is F and G, so it means that F equals G whenever X is -3 and whenever X is -1. Whenever X is -3, whenever X is -1, the functions are equal to each other. Right, so that is what we're able to note there. Moreover, now when is the product of the two functions negative? So you must study both cases. This one is negative here. This one is also negative. This is positive, 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 positive. This is positive, 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 and then negative. So now if you're multiplying these two functions, you're getting a negative. It means that you're multiplying a positive, a negative, and a positive function. You're multiplying a positive times a negative function. So, right, you're multiplying opposite signs. So here they're the same, but if you cut the graph like this, you really can see they're both positive. And obviously this is also positive all the way, but you're able to most certainly see something very interesting, that at this point here, the function is doing something interesting. So you're able to see that the function here from B to the right, one part is negative and the other part is certainly a positive part. So this would be when X is bigger than 1. When X is bigger than 1, one part of the function is positive and the other part remains negative there. Let us look at the next part of the question. In 5.6, sketch a neat graph of y equals x squared plus bx plus c in your answer book, given that this is the case. So A is negative, B is negative, and C is negative. When b squared minus 4ac equals 0, so obviously we are looking at the fact that it is our usual discriminant that equals 0, and this suggests that we have equal roots. Okay, so if we have equal roots, then what do we do to actually be in a position to sketch this graph? So surely this graph, without wasting much time, can be drawn exactly like so. Okay, given this is our y and this is our x-axis, and the graph is like this. The graph is exactly like this. So this is our y and this is our x, and therefore this is the case. Right, at this pointer, you're able to see that this is our y-intercept, our c is less than 0. And here you have that the discriminant, which is b squared minus 4ac is equal to 0. You have equal roots. All right, you have equal roots. Moreover, you have that b itself, a is negative. If a is negative, obviously you have a maximum vertex or maximum turning point, and you have that. And obviously you have as well that your b is negative, and this is going to be the shape of the graph, because you have to draw, or rather sketch, a neat graph of this in your answer book, and this is the sketch graph. Right, in question 6, we need to sketch below is the graph of the exponential function when a is bigger than 1. Point R is the y-intercept of f, and here is R, which is the y-intercept of f. T has the coordinates 2 and 9, is a point. Okay, this is Afrikaans, as a point of f. In other words, It is the point on F. They calculate the value of A. Right, to find the value of A, the couple of things that you need to consider, but you need to consider the fact that you have the function f of x, which is a to the power x, but this function itself passes through the 2 points, which is this, which means you have x and y, which means y is 9, a to the power x is 2. And we want to find the numerical value of a. So now to find the numerical value of a, we can take the square root here. So ordinarily, in principle, we have 2 square roots. We have plus or minus the square root of 9, which is the square root of a squared. And this gives us plus or minus 3. It is a, which means that a is 3. Okay. If a is 3 now, at this point, we want to calculate the value of a. So yeah, a is only 3. A is not minus 3 because of the fact that we're dealing with the standard exponential function. So we have that the equation is that. But what is the value of a? So we have that a is 3, and we've answered question 6.1. Write down the equation of the asymptote of f. So in 6.2 right now, if we agree that a is 3, what is the equation of the asymptote? It is this guy here, and it is exactly y equals 0. It is exactly y equals 0. That is the asymptote of the function. Next thing, write down the range of f. So let us look at 6.3. The range of f is a set of all the values of the function. So at this point, y equals 0, and this goes all the way up. And so what is the range? The range is y is greater than 0. That is the range. Write down the coordinates of point R. Write down the coordinates of point R. Right, the coordinates of point R are that at this point you have that the function itself, a is 3, so that y is 3 to the power x. And now at this point, to find the coordinates of R, this is the y-intercept. It is the y-intercept. To get the y-intercept, you let x be 0. Right, and then if you let x be 0 in the function 3 to the power x, when x is 0, you have 3 to the power 0, which is 1. At this point, you have that the coordinates of R are exactly x is 0 and y is 1, like that. Right, so now write down the coordinates of the point R. So the coordinates of the point R are 0 and 1 there. Okay, so we have that. Write down the coordinates of the point R, they are 0 and 1. Right now, the graph of f is obtained there. Right, so let's look at the next question. The graph of f is obtained. So obviously, if we know that the coordinates here are 0 and 1, so if we say the graph of f is obtained by reflecting the graph, rather the graph of g is obtained by reflecting the graph of f in the y-axis. So if you reflect this graph in the y-axis like that, you can take a point. So this point is going to be reflected here, and there's going to be a point t prime, and now x is going to be negative and y is going to be exactly that, and it is this like this. So the graph of f is obtained by reflecting the graph of f in the y-axis. Write down the equation of g. So how do you write down the equation of g? Right, so the equation of g, which is obtained by reflection, so it's going to have x that is negative. Okay, so when we can see that a is 3 here in this one, and the f of x was a to the power x, and then the f of x became 3 to the power x. So if the graph is obtained by reflecting the graph of f in the y-axis, write down the equation of g. So it means, therefore, that our g of x now, this transformation of reflecting in the y-axis, has the potential to take an ordered pair of x and y to the x becoming negative here and y remaining the same. So x is becoming negative and y is remaining the same. So at this point, our g is therefore 3 to the minus x, like that. So that becomes the equation of g. That becomes the equation of g. F is 3 to the power x. This now reflection in the y-axis makes the x to be negative, so that you have g is 3 to the power minus x. Right now, the last question is 6.6. Okay, I'm rounding up because I know very well that we have gone beyond time, and I'm just obviously 10 minutes beyond time, and I'm rushing to just make sure conclude discussion. If h is 3 times f of x, write down the equation of the asymptote of h. So in other words, right now we are building a new function in 6.6, and we're calling it h, which is 3 times f. And if h is this, which is 3 times f, what is f? Okay, we said that here a is the same as 3. Okay, we said that here a is the same as 3, and then f of x is 3 to the power x. So, and the f of x is 3 to the power x. And then now, if you multiply here, it is 3 to the power x plus 1. Goodness me. Right, so write down the equation of the asymptote. Right, so the asymptote, the question becomes, what is the asymptote of the function? So if you look at this function, the asymptote is noted by the constant there. Right, so the equation of the asymptote of h is still y equals 0, because it will actually be this, because that is what we have there. Okay, so it is exactly y equals 0, or it is also the x-axis. That is the equation of the asymptote of h. Right, Tando, I must thank you for joining us. It was awesome having a discussion with you. In our next appearance, we shall look at the second paper that was written in the same period, 2019, or another exam. But yeah, thanks a lot. This is what the June exam is gonna be containing as chapters. It was awesome having a discussion with you.